and then go to my screen and share it, and we'll get going. Alrighty, so remember, we're picking up in 9.5, and that was doing the properties of logarithms. So we're just going to call them logs for short. Alrighty, so this example, we're going to pick up on expressing in terms of sums and differences. All right, y'all, so they're giving us, this will be like number 9, so I'm going to try to number them to match these because these are sort of tricky. So we've got ln of 6 over 7 x to the 7th y. All right, so there's Jessica. Let me let her in. All righty, so let me get more in there. So I got Jessica, Misty. All right, so they're now starting to come in. All right, so the trick on rewriting these as sums and differences, if they're on top of these fractions, when we rewrite them, they'll be positive. And if they're on the bottom, when I rewrite it, they'll end up as being negative, because that's that quotient rule hitting them. And then you got to realize that 7x7y is like 3 different factors down there, okay? So we distribute the ln to everybody. So like I said, if it's on top, it's going to come out positive. On bottom will be negative. So I'm going to rewrite this as a ln of 6. So it was on top, it's going to stay positive. Everything else was on bottom, so that's going to give me minus ln of 7 minus the ln of x to the 7th minus the ln of the y. So our first move was to rewrite it from the fraction into the linear equation with the ln distributed. Now, we're pretty much done except for this x has an exponent up here. And what we got to do is utilize that power rule that tells us to bring these exponents into the front and rewrite that part as a product. So we would bring down the ln 6 minus the ln of 7 minus 7 ln of x minus ln of y. So we're not allowed to leave exponents up here behind the variables when we rewrite them as sums and differences. And then y'all right here would be your final answer. So it's going back through and using those 3 properties I gave y'all the other day, okay? All right, so this will be like number 10. A log square root c to the 9th b. So the first thing, you got to rewrite this without that radical. So I'm going to refresh you. When you got expressions under radicals, to rewrite them, you bring out the base, which is the a. The exponent goes to the top, and then you divide that by the index of the radical, which is the n. So the first thing I'm going to do is rewrite C9D, and I'm going to put it in parentheses because everything's under the radical, so everything is affected by the radical. And then we're going to rewrite the radical as a fractional exponent. So the top would be a 1, and then since there's no number here, you would treat that like a 2 so that you get a 1/2. So a square root always simplifies into an exponent of a 1/2. Now, you want to distribute this exponent so we can get rid of these parentheses. So bring down that log. When you got an exponent raised to an exponent, we multiply. So 9 times 1/2 would be c to the 9/2. So I'm just multiplying straight across. And just put a 1 under the 9 so that I can make that a 9/2. On the d, there's no exponent by it, so it's like a 1. And 1 times 1/2 would just be a 1/2. All right, so now I've got it rewritten as a product. I'm going to rewrite the product as a sum. So I'm going to get a log of c to the 9/2 plus a log of d to the 1/2. So products get rewritten as a sum. And then y'all, the very last move, once again, is to take our exponents and bring them down to the front so that we get a 9/2 log c plus a 1/2 log d. And then right here would be my final answer. And be done. So they're not too bad. You just got to keep up with exponents on these and remember all those exponent rules, okay? All right, so I'm going to write 11 right.
Okay, and then how did you say you got that 1/2 again?
So when you got radicals and say, because see, we didn't have, other than the 9, there wasn't no exponents under this, so you would treat all this like it was in parentheses under there, okay? And since there's no exponent outside those parentheses, I would treat that like a 1. Now, anytime you got a radical that does not have a number in the notch, it is automatically assumed to be a 2 on these, okay? So that when you rewrite them, you take the base, which is what's under the radical, and then you write the exponent divided by that index so that you get a 1/2. So what I did, I took all this that was under my radical, brought it out as my base, and then I had my exponent of 1 over 2 to make that a 1/2.
Okay, gotcha.
So I got a big one right here, so you'll get to see that bad boy in play, okay? Because watch this. This is a log base c, the 4th root. So this time we do have an index on this radical of a 4. Now on top I got an M16 N20. On bottom a C5 A5. So our first move is going to get rid of this radical. So we're going to bring down our log C. Now since all this stuff is under the radical, I'm going to put it all in big parentheses. My M16 N20 over my C5 A5. So the question is, what exponent will I turn this 4th root into? Well, the top number is going to be a 1. Because remember, this is like this thing's in a big parentheses with a 1 by it. The bottom number of this fraction will be the 4. So you basically just take these indexes, put a 1 over it, and be done with it. Now, up here, we distributed the 1/2 to everything in the parentheses. Here, we're going to distribute the 1/4 to everything in the parentheses. So we're going to have our log base C. So let's see what we get on top. 1/4 times 16 would be like 16/4, but 16/4 I can reduce to a 4. And remember, y'all could be multiplying these fractions on the calculators. 20 times 1/4 would be like 20 divided by 4, which would give me an n to the 5th. Now on the bottom, these numbers won't divide by 4, so I'm going to have fractions left. So on my C, 5 times 1/4 would give me 5/4. And then on my A, 5 times 1/4 would give me 5/4. All right, so all we did with everything so far was just getting rid of that radical, y'all. Now, I'm going to rewrite it as sums and differences. If it's on top, it's going to be positive again. And if it's on bottom, it's going to be negative. So I'm going to distribute the log C to everybody. So I got a log C m to the 4th plus a log C n to the 5th. So those were the only two factors on top, so they're the only two going to be positive. Then it's going to be minus log C, C to the 5/4, minus log C of A to the 5/4. So we've got it rewritten now with sums and differences. But remember, my next move, I got all these exponents. So all these exponents got to be brought down to the front. So this will give me 4 log C of m plus 5 log C of n minus 5/4 log C of C, and then minus 5/4 log C of A. And y'all, unfortunately, I've got one more thing to do to this. So I'm looking at the first term, nothing I can do. I got a log C with an m here. Nothing I can do to the second term. I got a log C with an n. But y'all look at this third term. You got log C of a C here. And we went through that property the other day when the log matches the base, and that result, all that equaled was a 1, which means the log C of C part equals 1, and we're going to multiply that 1 times that negative 5/4 so that that term becomes a negative 5/4. So my final answer will be 4 log C of the m plus 5 log C of n minus 5/4, and then at the end is minus 5/4 log C of A. So anytime you get this kind of situation and that base matches that result, you got to turn that into a 1. And then that right there would be our final answer. So that's the big one of them. So just remember, change these radicals into the fractions, distribute it, and then you're just rewriting, bringing exponents down, okay? Oh, and also, y'all should have got bonus thing from me last night. So don't forget about that, okay? All right. So now we're going to go the other way. We're going to express as a single log. And these started at about number 12. So we're going the other way now. So they're giving me a log C of 22 plus a log C of 45. All right, so since they're being added, we're going to rewrite these as a product. So that'll be a log C of 22 times 45. And y'all, we can actually multiply this one out. So let's see, that'll bring down my log C. And let's see what 22 times 45 will give us. So that gives me 990, so I get a log C of 990. Final answer. All right, let's see what we're going to do here. This one has a log 1000 minus a log of 100. So since these ones are being subtracted, we will rewrite these as division so that you bring the log over here. So this part was positive, so the 1000 goes to the top. This log is negative, so the 100 goes to the bottom. Now we can actually work this because 1000 will divide, 1000 will divide by 100, and that'll give me a 10. So the first answer you get would be log 10. And then Math Lab wants to know, can that answer simplify further? And y'all, we got a log button right on the front of the calculator. You can hit log, punch in a 10, hit enter, and you get a 1. So the final answer would simplify down to a 1. So on this number 13, it makes you do it both ways. You put in the log, and then you simplify that log down to your final answer. So remember, if it's just a log without a base, you can do that with the log on the front of the calculator. If your log had a base there, then you could use the log base that's in the math on that, okay? All right, so let's jack them up a little bit. How about a 1/4 log C of x plus a 5 log C of y minus 4 log C of x. All right, so the first thing I would do to this was move all the exponents back up to the variables. Because remember, that's the last thing I did before, so it's always going to be the first thing I do when I rewrite them. So that this one here will give me a log C of x to the 1/4, plus this one gives me a log C of y to the 5th, minus this one will give me a log C of x to the 4th. All right, so I've got them all written. Exponents are brought back up. So now I'm going to rewrite them as a single log. So I'm going to bring over my log base C. Remember, if they're on positive, I'm going to put them on the top. If they're negative, I'm going to put that factor on the bottom. So on top, I'll have a x to the 1/4, y to the 5th, all over the bottom, which will be a x to the 4th. So I would be done, but what's hurting me on this is I cannot keep x's on top and x's on the bottom because I can simplify that. So to simplify variables, you subtract exponents. So here's the trick. We always subtract the smaller exponent from the larger exponent and leave the answer where the larger exponent was. So when I come down here, on top, I'm going to have a y5, and on bottom, I'm going to have my x. I just got to figure out the exponent. So I'm going to take that 4 minus this 1/4 and see what that gives me. So let's see, 4 minus 1 divided by 4 gives me 3.75. But remember, you can hit math and enter twice. And what's that giving me? 15/4. So the exponent down here would be 15/4. Now remember, you could do 1/4 minus 4, but you would get a negative exponent up there, which means you can't leave the exponent negative. So no matter what, you would have to move it to the bottom and make the exponent positive. Okay? So just remember on that. Subtract the smaller exponent from the larger exponent. Alrighty, so let's see. I'm going to let y'all play with that. And so I'm going to move on to 16. This one has a ln x squared plus 6x plus 8 minus a ln x plus 4. So at the moment, nothing I can do with these parentheses. Exponents are already where they need to be. So I'm going to rewrite it as a single logarithm. So I got my ln. This is positive, so it'll be on the top. Over, this one's being subtracted, so the x plus 4 moves to the bottom. All right, so now we got to see if this simplifies. So for this to simplify, I've got to factor and cancel. So let's play with the top. That's a trinomial, so we know it will factor into nice parentheses. Y'all, the bottom is just the x plus 4. There's nothing I can do to factor that one. All righty. So since there's an x squared, we know there's an x and an x. That 8 is positive, so both of these factors will have the same sign as the middle, so they'll both be positive. And then I'm looking at factors of 8. You got 1 and 8, 2 and 4. I need to add to a 6, and the ones that add to a 6 are a 2 and a 4, so I put in my 2 and my 4. Now, you had to get a 4 anyway if this was going to cancel, because the only way to cancel an x plus 4 is with an x plus 4. So those cancel, and my final answer is a ln x plus 2. Now, when you do this on the MATLAB, make sure you put it in parentheses, because the ln affects the whole answer, the whole x plus 2. So let me show y'all something we can do on the calculator. If you're weak at factoring, you can hit the program button, go down to that factor number 7, and hit enter, and then enter again. Put in the numbers just like you would the quadratic formula. You got a 1, 6, and at the end is what, an 8? When I put in my 1, 6, 8, it will factor that into the x plus 4, x plus 2, and then you just move on, cancel, and be done. Okay, so not too bad.
I needed that all along.
Go ahead now. Oh no, I like to make y'all.
I needed that factor, but
I had to make y'all struggle a little bit. Just like on that quad, remember?
Oh yeah, now I know.
Y'all had to quad a little bit, remember? So. All right, and let's see. This one is a log x squared plus 8x plus 12 minus a log x squared minus 36. Well, got close to the edge, but that's an x squared minus 36. So nothing you can do to that at the moment, so we're going to rewrite it as a single log. And since it's being subtracted, this positive part will be the top. What's being subtracted will be the bottom. So I got my log x squared plus 8x plus 12 over the x squared minus 36. And y'all, both of these have some x squared terms, so I'm pretty sure both of these are going to factor into our two parentheses. Now, if you want to, that factor program will knock out both of those pretty quick. Watch, you hit enter. You got a 1, 8, 12. So the top factors into x plus 6, x plus 2. The bottom, you would do a 1. Since there's not an x in the middle, you would put a 0 and then a negative 36. Oh, dang, was I not on my program, y'all? Program, let me go back to factor. So the first one, oh, what was that? A 1, 8, 12. So there's my x plus 6, x plus 2. Usually if you hit enter, it starts it over. Okay, there it goes. So now I got a 1, 0, negative 36. And notice that factors into a x plus 6, x minus 6. So the top, you'd have found factors of 12 that added to get 8. That's 6 and 2. On the bottom, you'd have found factors of 36 that subtracted to get the 0, and that would have been 6 and 6. All right, so now you cancel out x plus 6 over x plus 6. So now your final answer is going to be a x plus 2 over x minus 6. In this one, I don't really need parentheses because it's just the one fraction there, and the log knows that it affects that whole fraction. All right, so y'all learned all this so we could do the stuff we're about to do. And that's solve equations in 9.6. All right, y'all, so here we go, 9.6. And this is solving exponential and logarithmic equations. So first I'm going to start with exponential. On exponential, we got a little property we call the base exponent property. And the base exponent property says if a to the x equals a to the y, then x equals y. So what you're saying is if you got two sides of an equation and you can write them with the same base and that base matches up, then the exponents by default got to be equal to each other. So in exponential equations, my first thing I'm going to try to do, can you rewrite using the same base? If so, rewrite it. And set the exponents equal to each other. Solve if needed. Okay, now, if you cannot rewrite, we take the ln of each side. Now it's ln, not in, so when you do these ln's on the math lab, you got to use the little ln or it won't make it bold and give you the answer. So we take the ln of each side, then solve for the variable. And always on an equation, if you want to, check answers if needed. All right, so here we go, y'all. We're going to solve for x. So number one, they give me 5 to the x equals 125. So the question would be, can I rewrite 125 using the 5 as its base? So we would bring down this 5 to the x. So let's see, 125, if I'm going to use 5s, let's see what we do. 5 times 5, that's 25. 25 times 5, oh, that's 125, so I did that 3 times. So this would be 5 to the third power. So rewrite 125 as 5 to the third power, which means now the bases match. And remember, we said, well, hey, if the bases match, rewrite it and set those exponents equal to each other, which means x has to equal 3. Hey, also, that's not bad. And if I put that 3 in for that x, 5 to the third power, and I can actually check that on my calculator, 5 exponent 3, hit enter, I get my 125. So these equations are probably funner than solving those fractional equations and probably even factoring. All right, here we go. We got 2 to the 5x equals 8. So let's see if I can rewrite 8 using a 2. So let's see, 2 times 2 is 4. 4 times 2 is 8. So since that equals 8, I'm going to rewrite the 8 using 2's. So bring down your 2 to the 5x. That's going to equal to 8, which is now 2 to the third. So see what we got. We got the bases match. Which means I know that this 5x equals 3. So this one's the part right here, solve if needed. Well, it's needed. So to solve this, divide both sides by 5. So that x equals, let's see, we can't do nothing with that 3 over 5, so that's going to stay 3 over 5. So if you put that 3/5 back in for the x, the 5's would cancel, and 2 to the third would equal 8. Okay? So that was just part 1, right? We had numbers we could rewrite using that base, so we were able to. So let's take a look at what happens when you're not able to rewrite it. So that'd be like my number 3 here. 4 to the x equals 19. Well, if I was playing with my 4's, I would have 4 times 4 is 16. And then I would have 16 times 4 would be 64. So there's no way we can rewrite that. So cannot rewrite 19 using base of a 4. So it said, if I can't rewrite them, I got to take the ln of both sides. So I'm going to take ln of both sides. So remember, that's ln, not in, okay? So that'll give me a ln of 4 to the x equals a ln of 19. And see, now you see that when I do to one side, I still got to do to both sides. So the reason I wanted to do that is because now you see this exponent up here, since it's written like a log or a ln, I can now move my exponent down to the front using the power rule. So that'll give me a x times the ln of 4 equals ln of the 19. Now, I'm going to solve for that x. And then right here, remember, what I was doing here is I had to move the exponent to the front. All right, to solve this, I got an x times ln of 4, which is a number. So I'm going to divide both sides by ln of 4 so that I get my x all by itself. So that the x, now since these are ln's, it's going to give us decimals, and we're going to round answer 4 places. All right, so when you do this, ln always gives you a parenthesis. Close those parentheses before you hit the division, and then put in your ln of 4, okay? So I would do my ln. So I'm going to pull my calculator over here.
My screen is frozen.
You better tell them to come back home. I don't need them making a mess over there.
Oh, that must be y'all's because I'm not showing on my end. Let me.
I don't know. It's frozen like on the part where your hands. I
I'm not
can't
moving
see
it.
anything.
Y'all can't see my hands at all? Or my calculator? Anybody?
No, it's frozen on where your hand is like. I don't know. Is it just me?
Denisha, is my screen frozen or are you seeing me move?
Your hand is frozen. Well, I can see you move now. You moving your hand.
I'm moving my hands,
Oh,
right?
yeah, now.
Yeah.
Okay. I don't
At
know
first
what
it was just in one spot.
All right, so
Okay, I thought I was tripping.
oh no, can y'all see me moving now my calculator? So I'm doing an ln of 19 divided
Yes.
by ln of 4. Now notice how I close these parentheses, okay? If you don't close parentheses, it won't do your ln's right. And then hit enter. I'm going to 4 decimal places, so I'm going to go to 2.12. Oh, let's see. Oh, look what's happening. The 9's rounding up because of the 6. So that means the 3 is going to turn into a 40. Okay, so the ones where you got to do the ln, you're going to have to approximate those 4 decimal places and then move on. All right, let's see what I got for number 4 here. 4 to the 7x minus 1 equals 16. So, oh, I can rewrite 16 using 4s because I know 4 times 4 is 16. So I'm going to rewrite the 16 using 4s. So this side will be 4 to the 7x minus 1. Other side will be 4 to the second power since I did that twice. Now look here, my bases match, which means my exponents are equal, so 7x minus 1 has to equal 2. All right, y'all, let's see, solve now. Solve for x. So it looks like we're going to add 1 to both sides. So 7x equals 3. And then divide by 7 to be done. And let's see, so I get a 1x and nothing I can do to the 3/7. But if you wanted to check this, you would put the 3/7 in for the x. So you would put a 3/7 here. The 7s would cancel. 3 minus 1 is 2. And 4 to the second power would be 16. So they're a little trickier to check, but they will check out for you, okay? All right, how about 3 to the x equals 2? All right, so there's no way I'm going to rewrite 2 with a 3 base, okay? So I cannot rewrite it, so we're going to take ln of both sides. So the ln of 3 to the x is going to equal ln of 2. And y'all, the whole reason we do that is so we can bring those exponents down and turn them into variables, okay? So remember, I got to bring the exponent to the front, so you get x ln 3 is going to equal ln of 2. See, I can't solve these while the x's are up here as exponents, but boy, as soon as I bring them down and get them in line, then I can, right? All right, so now we've got it rewritten. We're going to solve for the x, which means divide both sides by ln of 3. And so you always want things that sort of match up and look exactly the same when you do your crossing out, okay? All right, so once again, this is going to be an approximation because we got the LNs. So I would do my LN button, put in my 2, close parentheses, then divide by LN of 3, close parentheses, and hit enter. All right, so I get, what, a 0.63. Oh, that, ooh, that will stay a 9, so that looks like a 6309. Yep, because there's a 2 after it. All righty. Number 6 is a tricky one. I got 10 to the negative x equals 6 to the 4x. So no way I can rewrite the 6 and 10 to have the same bases. So my first move, I want to take ln of both sides. So that'll give me a ln of 10 to the negative x equals ln of 6 to the 4x. So now we got them rewritten as logs. We're going to bring our exponents to the front. This one will give you a negative x ln 10. That's going to equal this side, which is a 4x ln 6. So at this point, we're going to start trying to solve it for the x's, but I got an x on this side and an x on that side. So I'm going to move my x's to the same side. And what I'm going to do is move the negative one to this side by adding an x ln 10 to both sides. So at the moment, what's going to happen is this side is going to be a 0. This side will be a 4x ln 6 plus x ln 10. All right, now the variable is still in 2 spots, so the only way for me to get that variable from being 2 x's and turn it into 1 x's is by factoring it out as a GCF. So I'm going to factor out the x. If I factor out the x, that's going to leave you a 4 ln 6 plus this, when you take out the x, leaves a ln 10. All right, so now you got x times your parentheses. So we want to make that a 1x. So now we divide both sides by these parentheses. 4 ln 6 plus the ln of 10. 4 ln 6 plus the ln of 10. That cancels, giving me my x. And y'all, what's nice on this? That's a 0. And 0 divided by anything is going to be a 0. So if I put a 0 in up here, 10 to the 0 is 1. Over here, 4 times 0 would be 0. And 6 to the 0 is 1. So both of them will check out. So I think this one's a tricky one, that number 6, because you have to know about pulling out them greatest common factors on those x's, okay? All right, let's see, what's next? 7. E to the t equals 320. See, I see these, y'all, it makes me want to say phone home. Now, I'm not going to attempt to rewrite 320 using the E for the base, so I think I'm going to go straight into taking LNs of both sides. So my ln of e to the t equals the ln of 320. Now the reason I did that, because now that t I can move down to the front. I get a t ln of e equals the ln of 320. But y'all, what does the ln of e equal? Let's ask the calculator. We got an ln button right here by the 4. We got an E right above the division that's blue, so hit the blue button and the divide. That brings the E in there. And watch this, ln of E equals 1. Because remember, ln is really a base log E, and log base E of E is 1. So since this part equals 1, that's just going to give me a T over here. Now to work out this part, we would put in the ln of 320. In the ln of 320, looks like I'm getting a 5.768. And then let's see, that's a 3 with a 2 behind it. Alrighty. So that's why we love the ln when we do E-based exponents, because they cancel each other out, making it a 1 eventually. And all that's left is basically those exponents. Okay. All right, let's see. Oh, I'm going to do my number 9 next. 15 to the x equals 5 to the x plus 2. So y'all, once again, I'm not going to try to rewrite these bases, so I'm going to take ln of both sides. So doing that, I get a ln of 15 to the x equals ln of 5 to the x plus 2. And what we're going to do next is bring our exponents down to the front and rewrite this as a product. So this side I get an x ln 15. Now, since my exponent has 2 parts, I got to put my exponent in parentheses because both of those have to be multiplied by this ln 5. So before I move on, let's actually distribute the x times the ln of 5 and the 2. So left side is going to stay x ln 15. This gives me an x ln 5 plus a 2 ln 5. So basically, both of these exponents had to come down and get in front of that ln, okay? Now notice what we're going to do. I got an x here and an x here. These x's need to be on the same side, so I'm going to subtract x ln 5 from both sides. Now, I'm not worried about the 2 ln 5 because it didn't have an x. So it's going to stay on the side it needs. Now, these are not like terms, so x ln 15 minus x ln 5 is going to equal 2 ln 5. So let's see if we can remember. I got an x in this term. I got an x in that term. To turn an x from two terms into a single x, I'm going to factor out the x, so that you get your x times parentheses ln of 15 minus the ln of 5, all equal to your 2 ln 5. All right, y'all, and if you remember a while ago, I got an x times parentheses. I'm going to divide by these parentheses on both sides. So I'm going to just divide this side by ln 15 minus ln 5. And then the 2 ln 5 will also divide by the ln 15 minus ln 5. So that this will give me my x after that cancels. Now, let me show you, watch what I'm going to do. When you do the 2 ln 5, you got to close parentheses. Then you're going to hit divide. Then you got to start big parentheses. Put in the ln 15, close its parentheses. Put in the ln 5, close its parentheses. Then you got to reclose those main parentheses. If the bottom is not put in big parentheses, it will not give you the right answer. So I would do my 2 ln 5, close parentheses, divided by big parentheses, ln 15, close those parentheses, minus ln 5, close those parentheses. Now close the big parentheses, hit enter, and I get a 2.9. Well, let me see what's happening to all these nines here. 9299. After that's a 4. So that's going to stay what? 9299. So y'all, that was a doozy right there, because you had to realize that when you brought this exponent down, you had to put it in parentheses so that you could distribute it. Then you had to realize, hey, I need all the x's on one side to solve this. And then factoring out that x. Okay, so it's got a few steps that are sort of tricky on that one. All right, so now we're going to play with the logs. So to solve logarithmic equations. So my ultimate goal on these is so that I can use my log base property. And this is almost like the base exponent property. But if I got a log base a of x equals a log base a of y, then, so if the logs match bases, then that means that x has to equal y. Okay, so on the logs, my first thing is I look on each side. Can I combine logs? So if needed, rewrite each side using single logs. At that point, I can then rewrite as exponential equation. So I'll go from the log to the exponential, and that's why y'all were having to learn the other day how to transfer from the logs to the exponential and back and forth, okay? All right, after I rewrite it as an exponential equation, my third step, I'm going to solve for that variable. And then finally, check if needed. Now, the ones I do today, we don't really have logs on both sides, but once we come back Tuesday, it starts picking up into equations where I got logs on both sides. So if I got time, I'll show you one of those. But I'm going to pick up at my number 10. So these are still saying solve for x. So y'all, this one has log base 5 of x equals 4. So I've already got single logs, and I don't have logs on both sides to use that property. So we're going to write this as exponential. So we take the base, which is 5. So remember, 5 is the base. 4 is my exponent, and that means 5 to the 4th has to equal our x. All right, so I think I can do that, and let's see. 5 times 5 is 25. Times 5 is 125. Times 5 is 625. So that means my final answer is 625 equals my x. So I sort of like these ones too. So watch this one. Log of x equals -3. So you got to remember one thing. If there is not a number shown for the base is a 10. So I got my base. My exponent is my -3. And 10 to the -3 is going to equal my x. Alrighty, so let's see. We can punch that on the calculator. 10 to the -3rd is going to give me 0.001 as my x. Okay? All right, let's see what I'm going to put my number 12. I think I can get it right here. Log base 5 of 5x minus 5 is going to equal 2. Alrighty, so there's not logs on both sides. I got a single log, so I'm going to rewrite as exponential. Oh, and I did that here. I didn't write that though, did I? So we did rewrite that as exponential 2. So base is 5. Exponent is a 2. And that's going to equal that result of a 5x minus 5. So the first thing I would do to solve this would turn that 5 squared into a 25. Now, solve that, get that x by itself, so add 5 to both sides. So notice that gives me 30 equal to my 5x. So let me bring that up. And the last step would be to divide by the 5. So 30 divided by 5 gives me 6 equal to my x. Well, let's see. 6 times 5 is 30. 30 minus 5 is 25. And log base 5 of 25 is 2. Because 5 squared would equal 25, okay? All right, y'all, so moving on. log x plus log x minus 3 equals 1. So now I do got to rewrite as a single log. So we're going to write as a single log. Since they're being added, we will rewrite them as a product of x times x minus 3. All that's going to equal 1. Okay, so all we did was rewrite these two factors as a product. And we're going to go even further and multiply that stuff out. So x times x is an x squared. X times a negative 3 would make that a negative 3x. All this is equal to a 1. So I've got my single log. Now I'm going to rewrite as exponential. So my base is not shown, so it's a 10. My exponent is the 1. And that's going to equal the result of an x squared minus 3x. So to solve this, I need everything on one side equal to 0. So 10 to the first is basically 10. So I'm going to subtract the 10 from both sides. So I get my 0 equals x squared minus 3x minus 10. So at this point, you can hit it with the quad or you can factor it. And you can even factor it on that calculator now, remember. So I'm going to factor it and solve it. So I got an x and an x. That's a negative 10. So one's positive, one's negative. Factors of 10 that subtract and get 3 are 5 and 2. 5 is negative, 2 is positive. So your larger factor always has the same sign as the middle. Then you would take both of these and set them equal to 0. And y'all have seen enough of these by now to see that the factors always had opposite signs than the actual answers or zeros, right? Now notice, oh, let me let one back in. That gave me 2 answers, but I got to check these answers because watch this. You see you got a log up here, a log of the x's. Well, what's going to happen when you do a log of a negative 2, you're going to get a non-real answer. So you cannot take answers that make these logs negative. Now look, 5, I can take the log of a 5. Log of 5 gives me, whoops, log of 5 gives me 0.69, which is an answer. And if I put the 5 here, 5 minus 3 would be 2. And I can take the log of a 2 and get an answer. But what I couldn't take the log of was a negative 2, okay? So check answers. If the answer makes that log negative, you got to reject it so that your only answer is 5 on that one. All right, so I do got time to do the one that I was talking about where you get a log on both sides. All right, so here we go. We got a log base 4 of x plus 14 minus log base 4 of x plus 6 is going to equal log base 4 of x. So log base 4, x plus 14 minus log base 4, x plus 6 equals log base 4 of x. So y'all, the first thing we're going to do to this is rewrite this side as a single log. And just remember, they're being subtracted so they look like division. So that's going to give me a log base 4. This is positive, so it goes to the top. The x plus 6 is being subtracted, so it goes to the bottom. And all that's going to equal your log 4 of x. So look, the logs match. So since these logs match on both sides, that means that this result, x plus 14 over x plus 6, has to equal that x. So what I'm going to do to this is solve it for the x. Easiest way to solve this is to put a 1 under that x and cross multiply. So take this top times 1. That's going to equal the other top times that bottom. So that's your cross multiplying for you. Just remember, treat that like a 1 there. And 1 times x plus 14 is just x plus 14. But over here, you get an x squared plus a 6x. So what we want to do, since we got an x squared term, is get both of these on this side. So I'm going to subtract the x and subtract 14 from both sides. So we can do 2 at 1. So this side is now a 0. That side is an x squared. 6x minus x left me 5x. And then my minus 14. So at that point, you could factor or quad. I'll factor real quick. Get y'all more practice. That's an x and an x. Or factor program on the calculator would knock this out. All right, that's negative. So one's positive, one's negative, no matter what. And then you want factors of 14. That'll subtract and get 5. That's 7 and 2. Larger factor has the same sign as the middle. And then you would what? Set both them equal to 0 and solve. So here I get a negative 7. Here I get a positive 2. So let's see what that negative 7 will do. Negative 7 plus 14 makes that a 7. That's all right. But right here, negative 7 plus 6 makes that a negative 1. So that fails. And right here, if you put a negative 7 in for the x, it would give you an error message. So I cannot take that one. Let's see what happens when I put a 2 in. 2 plus 14 is 16. That's positive. 2 plus 6 is 8. That's positive. And then if I put a 2 in for the x, that's positive. So it will work for the positive 2. So on those problems like these two, you better check those negative answers because you cannot take the log of a negative answer on those, okay? All right, y'all, so I'm going to finish that right there. So I'm going to stop this screen. Y'all got that written? All right.
Yes.
All right, mine's being slow. All righty. All right, now I'm just going to stop our recording.